Hello class, this is Algebra 1, 7.1, Chapter 7.1. We're talking about number line solutions today. Today is a very simple idea and concept to understand. Let's say we had a number line. We have our 0 in the middle, got a couple numbers to the left. Those are our positives. And then we go to, that's the right. And then we go to the left, -1, -2, -3, -4, and so on to negative infinity. What we're going to talk about today is called graphs of a number line, or graphs of a solution. And the way that's written is like this: graphs of a solution. So here's the simplest graph of a solution on a number line. I give you the equation x is equal to 2. What I've told you is that somewhere on this number line, there is a point called x, and it's worth 2. How do I represent equals 2? Well, I simply put a dot right at positive 2. Some people like to put the letter that is talking about on top of it, but all you need to do is put the dot at x equals 2. What I've shown you here on the number line is a graph of the solution x equals 2. Now let's say I told you that there was a y equals -3. Well, very simply, I would go to where my -3 is on the number line, and I would put a dot there. And if I wanted to, I would put the y on top to say y is -3. And so you can see that if it's an equal sign, you just put a dot on that spot. That's good, a dot on the spot. Dot on the spot. Okay, that's for equals. Now let's talk about if something is greater than or less than, okay? If I have an inequality that is less than, it would look something like this. Let's say x is less than 2. So conceptually, what I'm saying is whatever x is, I don't know what it is precisely, but whatever it is, it's less than 2. So I go through my mind. I say, all right, I start with 2. Is 2 less than 2? Well, no, 2 is equal to 2. So it can't be 2. Is 3 less than 2? Obviously not. 3 is 1 more than 2. So it can't be 3. Let me go the other way. Is 1 less than 2? Yes, it is. Is 0 less than 2? Yes, that is. Is -1 less than 2? Yep, sure enough. So how do I mark this, or how do I graph this on a number line? Very simply, I go to my reference point, and my reference point is 2. X is less than 2. So on the spot called, I'm trying to erase this right here. On the spot called 2, I say I'm going to put a open circle to show that that's where I'm starting, but I will not close the circle. It's not a dot. It's not a dot because my value is not equal to 2. All it says is that it's less than 2. So I put an open dot on 2, and then I highlight or I shade all of the numbers that are in fact less than 2. And that's every single number that's to the left of 2. I've shown you with a green little squiggly line. All of those numbers are less than 2, but not including 2, okay? Now, let's say instead of less than 2, it told me x is less than or equal to 2. You notice the equal to 2 has a line underneath the little alligator mouth, the bracket, or the caret, whatever it is. In this case, because it includes 2, it is equal to 2 as well. I now need to close the circle, and it represents everything that is 2 and everything that is less than 2. If I wanted to do x is greater than 2, well, I just need to think about all the numbers that are in fact larger than 2. All the numbers that are in fact larger than 2, I'm going to erase this so it doesn't confuse us. All the numbers that are larger than 2 are 3, 4, 5, 6, 7, 8, 9, 10, all the way into infinity. So on my number line, how do I denote this? How do I mark it? I start my reference point, which is 2, but not including 2, because it's not equal to it. And then I go everything to the right that is larger than 2, all the way into infinity. I said 2 a lot there. 2, 2, 2, 2, 2. Let's try another number so we don't get annoyed. Let's say x is greater than, oh, here we go, -3. So what do I do here? Well, I say to myself, what's my reference point? My reference point is the -3. Does it include -3? No, it does not, because it does not have a line underneath it which says it is equal to -3. All it says is that x is bigger than -3. So I draw a line, I draw an open circle at -3, and x is everything that is bigger than -3, so everything bigger than -3 is to the right, -2, -1, 0, 1, 2, 3, 4, 5, and there is the graph of that equation. Let me show you now what it looks like to have x is less than -3. Here's my number line again. Here's 0, -1, -2, -3, -4, -5. And here's my inequality. X is less than or smaller than -3. Okay, so what are all of my values that are, well, let's start at the beginning. What is my reference point? -3. Is it including -3? Is it equal to it? No, it's not, because there's no line underneath it. So I start at -3, and then it's asking me for everything that is smaller than -3. And everything smaller than -3 is to the left, -4, -5, and everything to -infinity. All those numbers are less than -3. All right, so those are solutions where you have a greater than or a less than symbol. Let's talk about what happens when you have an equal symbol with it. So here's what I'm going to graph. I'm going to graph x is, and it doesn't always have to be x, right? So let's try another number. Y is less than or equal to 4. Let's go z is, I'm sorry, that was greater than or equal to 4. Z is less than or equal to -1, and let's go b is greater than or equal to 3. All right. I'm going to pause for a couple seconds to see if you can figure this out before I do. Let's start with the first one. Y is bigger than or equal to 4. How would you graph it? All right, that's enough time. Here's how I would graph it. I start with the number line. I put a 0 down. I go over 4. 1, 2, 3, 4. I label. Then I say, what's my reference point? It's 4. Is it equal to the number or to the values? Yes. How do I know that? It has a little line on the bottom. So I'm going to draw a closed circle on my reference point. My next step, is is 4 greater than or is 4 less than the information? Well, it shows us that y is bigger than 4. The alligator always eats the bigger thing. So it's all the numbers that are bigger than 4. So all the numbers bigger than 4 are 5, 6, 7, so on and so forth, going to the right all the way into infinity. And that's it. You've got the closed circle starting at 4 because it's equal to, and you've got the arrows going to the right. Let's try this next one. 10 seconds. See if you can graph it before I do. Z is less than or equal to -1. Okay, so here's what I'm thinking. My reference point is -1, so let's put a circle there. It's equal to, so I close the circle. My next step is the alligator is pointing and trying to eat the -1, which means -1 is the biggest thing here, which means everything to the left of it is what Z is. Z is everything to the left of -1. Or another way I could say that is any of those numbers that are smaller than -1 could be Z. That's how you think about it. Let's try the last one. B is greater than or equal to 3. 10 seconds. All right, here's what I'm thinking. I start off with my reference point, which is 3. I put a circle on it. Do I close the circle? Yes. Why? Because there's an equal sign underneath. There's a line underneath the caret, which means equals. And then B is any number that is bigger than 3. So what are the numbers that are bigger than 3? Well, that's 4, 5, 6, 7, 8, all the way to positive infinity. So all of these values could be B. And that's it. That's how you graph inequalities. Inequalities are any statement where you have numbers or letters on one side, a value on one side, an inequality sign like this or this, and then another value on the other side. And that's how you graph these inequalities. An equality would be something like this. X is equal to 4. Why is it an equality? Because both sides of the statement are equal. X is 4. In an inequality, X is not 4, it's greater than 4 or less than 4 and sometimes even equal to 4. But that's how that works, inequalities. All right, if you have any questions, let me know.